Okay, now we're going to make some bar graphs for our t-tests and some mosaic plots for our chi-squared tests. So our first hypothesis was that women will enjoy romantic movies more than men, and I have the t-test code here. This is actually going to be important this time because we want to know what the significance was between these groups because we're actually going to add that in manually using a visualization. So this was significant less than 0.001, the difference between the mean for females and the mean of males. Okay, so here's the code for this visualization. First, we want to summarize the data using the tidyverse. So we actually need to get the data into a table that has mean values in order to make this work effectively. So I take my data and I pipe it into the filter function in tidyverse. You can take our tidyverse series to learn a little bit more about these functions. And then I use the exclamation point, which is not. So is not is NA gender. So I'm selecting everything except for the NAs for gender. I then group the data by gender because I want a mean for females and a mean for males. So I'm grouping that data together. And then I summarize by creating a mean of the dependent variable for each gender. So I'm creating a mean romantic for females, a mean romantic rating for males, and then of course you need to put in the NA remove equals true, otherwise this will give you an error. And then here is where we use the code that I wrote up before that I had you run for the standard error. Now all we have to do to calculate the standard error is just put in standard error because that's what I called my function name, tag the variable, and then we added in an NA remove equals true option. Okay, so that's how you set up your data for this plot, and if you just run it up until that point, you can actually see the table that you're going to be using to make your plot. It's just a little table with male, female, the means, and the standard errors for each of those. And I just went ahead and piped this straight into my ggplot, so you could save this as a new data set by adding an arrow here and giving your data set a new name. And then you would put the data set name right here at the beginning of ggplot. But I went ahead and just piped it in, so you don't need to tag the data again here in ggplot. And then went ahead and tagged the data that we're using. The data always goes after this AES, the mappings for the data. And then usually it goes X variable, Y variable. So I put in gender, and then I put in mean, which will be our Y. I'm using a geom bar because this is going to be a bar plot, and then whenever you use geom bar, the default is count, so you can't use it with a Y variable. So if you have a Y variable there, then you also need to add stat equals identity. I changed the width of these bars to be a little bit skinnier because the default was really fat, and then I filled them with a color that I like from the website that I showed you. I also added error bars, so you actually add in different data for the error bars. So you do an aesthetics mapping, and then you have to tell it what the Y minimum and the Y maximum is for the error bars you want. So we want the error bars to be the mean minus the SE for the minimum and the mean plus the SE for the maximum. And then you can change the size of your error bars if you want. This last line of geoms is for significance. So this allows us to add lines that compare the two groups with an annotation. So this is where you need your results for. You put in the comparison. So we're comparing female versus male in terms of gender. And the annotation that I want to add to that is 3 stars because its p-value is less than 0.001. And then I added a title that was good for this. And then for Y, it was just going to put romantic. Or mean, it was just going to put mean because our Y value up here was mean. And I wanted that to be romantic mean, so I went ahead and changed the label of the y-axis as well right there. And then I am showing you a different theme here, which is the classic theme. And there you go. You can see the geom significance. Added this little comparison bracket with the 3 stars. We have our error bars. This is the color I chose, this Misty Rose 3. I feel like it's a good neutral color. And then I changed the name of this to be Romantic Mean, and I left that as the default, which was gender. Okay, now we are going to make a graph using this code for our next hypothesis. So I'm just going to copy and paste the same code, and then my second hypothesis, yours might have been different, is that only children will have more friends than people with siblings. This was not significant, so I could just change this here to NS and have the line go across and be NS, but I'm actually just going to get rid of that completely for this graph. I think it'll be pretty apparent that there aren't any differences here. Okay, so is NA, we want this to be our grouping variable. So that's going to be only children, or only child. We're going to group by only child. And then the mean that we're calculating is for the number of friends. And then we're going to do the same for SE. And then in our ggplot, we're going to first tag the group variable, which is only child. And then it's still going to be mean because we changed what the mean was calculating here. It's still called mean. You can call this whatever you want. It could be mean too. So we'll just leave that as mean. We'll leave that the same. Our error bars will be the same. The title, mean comparison of number of friends by sibling status. And then the Y mean that we're measuring here is mean number of friends. And I'll go ahead and use the same theme for this. And here we go. You can tell that those are really similar. The error bars overlap with each other. And, oh, we might want to change this X label down here because it says only child. So in order to match our label, we might add X equals sibling status. And you use these single quotations here because usually you use single quotations when there's something with a space in it, and then if it's something without a space, you use the full quotation marks. So let's go ahead and run that. There we go. Okay, now for the chi-squared test, we're going to do mosaic plots. So our first hypothesis was that only children will be left-handed more than children with siblings. You can go ahead and run this again. It shows you that this was not true. They were left and right-handed a similar amount. And then here's the visualization for this. So I'm actually not using ggplot for this. Mosaic plot, I find, is the easiest way to do this. So first you tag mosaic plot and then you put in the equation. So here we're comparing only child and left right-handed. If there were more variables, you could go ahead and add plus, 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 and add all of the different variables. The X label I titled only child, and then the Y label I titled left or right-handed, and I gave it a main title name. So the notations on this are a little bit different since it's not a ggplot, but in order to see what the options are for that, you can just do a question mark mosaic plot, and it will show you the options down here in the corner. Okay, let's go ahead and run this. And it just shows you the proportions of people in the different groups. So you can see that maybe 10% of people were between 5 and 10% of people were left-handed, and it was the exact same amount of people for people who had siblings and people who didn't have siblings. And then, of course, more people had siblings than did not. If these labels are showing up as numbers and you want them to show up as these words, then you need to turn those variables into factors like we did up here. So we gave these factors labels here, and that's why on this plot, these things are showing up as words, but they could show up as numbers if you don't do that. Okay, now for hypothesis 2. We had males drink a lot and drink socially more than females. So we'll do alcohol and gender. Both of these we already turned into factors, so this should be good. For the X label, we're doing gender. And for the Y label, we'll do alcohol affinity, alcohol behavior, drinking behavior. Okay. And then we'll title the graph comparison of drinking behavior in males and females. Oh, whoops, I got the labels wrong. So we're just going to change the X and the Y here. Okay, so now we have drinking behavior. You can see most of the sample were social drinkers, followed by heavy drinkers, and then never drinkers. And you can see females were social drinkers a little bit more than males, and males were heavy drinkers and never drinkers a little bit more than females.